quantum technologies. The system would be able to respond to emerging challenges in real time, adapting to challenges quickly, and making data driven decisions in situations like natural disasters, health crisis, or cybersecurity threats. Another potential breakdown of yesterday's session key points included the quantum computing and AI synergy, which explored how quantum computing can enhance AI models, allowing them to process vast amounts of data more efficiently than classical computers. Quantum algorithms could enable AI systems to solve complex optimization problems faster, improving the speed and accuracy of decision making. Nevertheless, the second session on quantum image processing provided a comprehensive overview of how quantum computing principles can revolutionize image processing tasks. The key highlights of the second session were introduction to the quantum computing, quantum image representation techniques, quantum algorithms for image processing, current limitations, and the overwhelmed challenges. The quantum computing also related to the basics, including the concepts like cubes, superposition, and entanglement. Based on the quantum image representation techniques, discussion were on the encoding classical images into quantum states, like methods of flexible representation on quantum images, novel enhanced quantum representation, benefits of quantum image representation, such as exponential speed up, reduced storage requirements, etc. Certain quantum algorithms for image processing were also discussed, such as quantum edge detection, image compression and noise reduction, pattern recognition, and feature extraction. The future prospects, and the potential applications in fields like medical imaging, remote sensing, cryptography, and AI also marked the significance of the second session. So, nevertheless, now to move forward, we are on the day two of this AICT sponsored ATAL FDP, and we will start our session with Dr. Devashish Das with the topic as generative AI with edge intelligence. But before that, I would like to invite our convener of this FDP, Dr. Papia Datta ma'am, to say something about Dr. Das.
Thank you, sir. I hope I'm audible. Dr. Debashish Das works as an associate professor in Department of Computer Science and Engineering, also associate faculty in the School of Artificial Intelligence and Data Science at IIT Jodhpur, Rajasthan. He remains the coordinator Center for AIoT and Applications of the IIT. His active areas of research interest comprise Internet of Things devices, artificial intelligence, machine learning, and blockchain. Dr. Das published 150 research papers in top international journals like IEEE Transaction, ACM Transaction, etc. And the top received the top conferences. He has 20 sponsored projects and 2 consultancy projects to his credit. He received the Early Career Research Award in 2016, the Young Researcher Award Engineering Research Board by SIR, Department of Science and Technology, Government of India. He has various research collaborations with premier institutions in India and different universities around the world. He has been actively involved in various academic pursuits both within and outside the institute. He has guided 5 PhD students and 8 are still continuing their thesis. More than 30 ME Tech students. He is a senior member of IEEE and VTS and a professional member of ACM. Thank you, sir. We'll start your session now. It's over to you.
Thank you. Thank you for invitation. Okay, so just I'll share my screen. So it is visible.
Yes, sir. Visible.
Okay. Okay. So, good evening, all of you. So, today I'm going to discuss the generative AI, okay, as well as the age intelligence. So, age intelligence based generative AI type of concept nowadays, which is the most popular topic and as well as a hot topic in the all areas. Okay, so so the main objective is in this talk. First, we understand what is the AI or what is machine learning. Then the next one is on the generative AI or advanced AI. And then we have the edge intelligence and how we integrate the edge intelligence and generative AI. What are the benefit we are getting? Okay, and what type of challenges we solve? And then top of this, how we integrate the quantum computing thing. Okay, so which is basically the quantum edge intelligence or edge quantum computing or hybrid edge quantum computing type of concept. Okay, but these are the technology. Okay, so through this technology, we can solve the multiple complex problem. Okay, but how we define the complexity? So those things I'll discuss in this talk. In between, if you have any query, anything, I'll be happy to answer those query. Okay, so I'm basically from Computer Science and Engineering Department, IIT Jodhpur. Okay, so the Jodhpur is in the blue city, so our all the houses, okay, and everything is in the color is blue. Okay, so like this is the city view. So all the houses is in the blue, and as well as we have the one most popular fort, okay, Mehrangarh Fort here. Okay, and this is also a picture of the fort. Okay, and then from the city around 20 kilometer. This is the IIT Jodhpur campus. Okay, so around 1,000-acre campus. And here we have the multiple programs. Okay, we have the multiple BTech program with the specialization computer science and engineering, AI. Then we have the electrical engineering, mechanical engineering, as well as the around we have the multiple PG program like the MSc, MTech, as well as we have the all around PhD program, the all department. Okay, and these are the our basic academic structure, and this is our industry structure, which is basically the Section 8 company. Okay, so which is the collaboration of the government as well as the different private partner. Okay, and these are the companies. So basically, all these companies are the Section 8 companies. So like the iHub, GST, Tech Park, TISC, Jessica F, okay, AIoT Innovation Hub. So here we basically develop as well as the design the different type of the product, okay, and related to the AI as well as the quantum computing as well as the edge intelligence as well as the different IoT related product. AIoT means artificial Internet of Things, okay, and as well as we have this Jodhpur City and Knowledge Foundation. So here also we develop the different, we basically working on the different types of problem, society related problem, rural problem, water problem, okay, health problem, okay. So these are the, and we develop and deploy the large number of solution for this. Okay, so these are the our innovation ecosystem, which is basically responsible for develop the product as well as the generate the revenue for the ecosystem. Okay, and these are our academic units. Different okay, we have the different academic units like the biosciences, bioengineering, chemical engineering, computer science and engineering. Then other than academic unit, we have the schools and interdisciplinary research division, and as well as we have the multiple centers. Okay, so Center for Education Technology, Center for Technology and Foresight System, and as well as Center for Sustainable Development. Okay, so this is a video. It is available online. You can go through it. Okay, and I'm basically from Computer Science and Engineering Department, and these are the our okay placement. Basically, these are the companies. Okay, for the placement, and we have the these are the computer science department. We have the 25 around 25 regular faculty. Other than regular faculty, we have the adjunct faculty and other guest faculty and departmental advisor. These are the multiple labs in our department. we have the quantum lab as well as we have the machine intelligence lab, edge intelligence lab, and cognitive and social analytics lab. So all the labs are, if you check, the related to the technology, either AI or machine learning or edge computing or quantum computing or as well as the different networking and communication related thing. Okay. And these are the areas all faculty member in the CSC department, they are working, not only quantum computing, communication, security, blockchain, okay, as well as the deep learning, computer vision, software engineering. Okay, so all these area, almost all the computer science area, all the faculty member, they are working and they have the large number of projects, okay, national, international project and large number of PhD student, master student working on this project as well as the multiple research scientists also working on those projects. And I am the coordinating this lab, this regular ad hoc network lab, which is in the CSC department. Okay, so we are working on the quantum computing as well as the edge intelligence and generative AI, ML, security. Okay, and these are the multiple lab members. Okay, from the master and PhD students. Okay, we develop and deploy the multiple solutions. Okay, so now I'm going to discuss the what is the trend of the AI and email. Okay, so artificial intelligence, machine learning is the hot topic nowadays. Everyone want to do the machine learning, and as well as not only everyone want to do the machine learning, not in the terms of education, in the terms of knowledge, as well as all the product. If you check the all the like mobile, you have the AI content. Okay, AI enable voice recognition system or somehow in your AC. Also, there is the AI enable thing in your TV, television. Also, there is the AI enable concept. But this is not the hot topic. Okay, so but why we need the AI? Okay, so this is the main question, and as well as the we have the in future also advanced topic like the quantum system, just I mentioned. Okay, and edge computing also play the important role for this top of the AI. Okay, so that's why I'm today I'm going to discuss this thing, the edge intelligence and so why the AI? So AI means whatever we know the AI means it is a software, but it's not or whatever that we use, which is the AI services. Okay, so large number of things is under related to the AI services. Okay, but other than we have the AI hardware and AI software. Okay, so expected to the generate the revenue in this area is in the use and as well as the worldwide. Okay, according to the this is according to the this is the revenue generated by the AI hardware, AI software, and AI services expected to the reach up to the around 200 billion. Okay, worldwide. Okay, so according to the market research. Okay, so then everywhere we have the AI. But what is the responsibility of the AI and why we need the AI? Okay, so this is the main thing. Then we move into the what is the edge intelligence and other concept. Okay, so if you check that this is the market research. Okay, in the year of the 2024 till now we are here. Okay, so here this one is services. Just I mentioned the services. Okay, so we have the services is a large number of part is in the percentage in the services. Then we have the software and least number of the part in the term of hardware. So this is the growth rate, okay, which is the 24.5%. Okay, so which is a huge growth rate in this area. So that's why the large number of people and not only people as well as all the companies as well as the ministry, government, everywhere they want to do the AI thing. Okay, so now what is the additional thing? We know everything is under like AI thing is available 20 years or something, but nowadays, which is most popular and all companies are working on this area. But because 20 years back or 30 years back, we have the theoretical concept. Okay, now the term is machine learning is there, which is give you the find the hidden insights through the iterative learning process of the data. Okay, from the data. So here our objective is basically we our objective is previously only decision making. Now we also find the hidden insight. So we have the sorting, searching type of thing. All these things are available, which is normal thing. Okay, here we identify, find something, number or find the any object. But here we find the hidden insight. And what is the technique we use? Use the iterative learning technique. Okay, so it is learning from the data. Okay, so this is the basically main concern in this case. Okay, and this is the AI is another one type of yeah, means ML is another one type of the AI. Okay, and machine learning they're saying this ML or machine learning, it is, if you check, it is use the historical data is a input and predict the new output value. So this is the our concern. We predict the new output value, and this output value give you the hidden insight through the iterative process. This is the main concern. Whatever the machine learning algorithm we use, either SVM or your random forest or decision tree, whatever the machine learning you can use, you are basically focusing on the only the historical data as the input and predict the new output value. Okay, same thing in the deep learning also. Okay, now human can learn from the textbook and machine can learn from the data. This is the basic concept. Okay, so like human intelligence and machine intelligence. Okay, so human intelligence is at the basically focus on the how the human intelligence. If you have the intelligence, we have the learning material, and through the learning material we can develop the our skill. Okay, like you have the knowledge, you can learn the Python code, and finally the you are a Python developer. Okay, same thing in the case of your machine learning models. Okay, there is a model learn from data, historical data, and finally you can identify the output, and this output you created the output based on the learning by ignoring or interleaving learning or learning by creation of the test cases. Okay, so these are the thing. Okay, so this we have the three things. One is the computer science. We know where we have the software hardware part. We have the machine learning, learning the pattern, and top of this special type of the pattern, and which is inspired by the human brain, which is the deep learning concept. Okay, so here we have the different type of the deep learning algorithm, basically the neural network type of algorithm, and we have the open source technology. Okay, and we have the large data set, we have the label data, we have the engineering expertise and specialized hardware. Means nowadays the GPU based hardware or GPU based system, these thing is the important for the in the case of deep learning or machine learning. Okay, so in general we have the training data, then we have the machine learning algorithm models. Okay, and then the you have the machine learning algorithm, and you have the input, and you predicted the some value, and then you trained the whole models. Okay, so like this way. So you have the training data, you have the input data. Okay, training data is trained your model, and based on the trained model, you calculate the input to predict the output. Okay. So machine learning, all of you know most probably supervised, unsupervised, reinforcement learning. So that's why I don't want to discuss more. Supervised means labeled data, where unlabeled data, and in this case, learn from mistake. Okay, so where we have the reward and penalty type of concept. Okay, so this is the machine learning concept. We have the feature instruction. Here we have the deep learning model. Through the deep learning model, we can learn our network. Okay, different types of application. Application can be stock prediction, okay, as well as the weather forecasting, anomaly detection, okay, healthcare, navigation, okay, recommendation system, all these cases. In general, we have the namely the three category, what I discussed, supervised, unsupervised, and reinforcement. Other than we have the semi-supervised, online learning, transfer learning, okay, these type of concepts are there, okay. Now, in the machine learning, just I mentioned, we have the training and testing, two stages. Training stages, the model is learned based on the training data, and in the testing stage, trained model is applied for the prediction. Okay, so training is not required in this case, only testing. Okay, so so these are the things. So machine learning is it is the important field and potential in the solving the traditional problems. Okay, so this is the in general the neural network model we use for the solve the type of problems. Okay, other than machine learning, just I mentioned we have the blockchain, smart grid, 5G, Internet of Things. These are the research areas. Okay. So now we focus on the different types of the AI system component. We have the machine learning thing, cognitive computing, vision, natural language processing, neural network, all those things. Different types of application just I mentioned. Now we have the edge computing. So what is edge computing? Edge computing is an the extension, basically the extension of the your cloud computing, and where the basically cloud is centralized. So when we create the distributed type of environment, then the edge computing is another play the important roles. Okay, so edge computing, why? In between the our any application, we create the edge in between the our cloud and our user. Okay, so what is the benefit? So every time you not depend on the cloud, you connect the edge and easily you communicate with the edge and transfer the some informations. Okay, and which is important for the some of the safety critical application. Okay, so that's why the edge computing offer the virtual computing platform, which is providing the computing, storage, and network resources. Okay, so edge computing providing the computing, also provide the storage, some type of the storage. It's not like the cloud, as well as the networking resources. Okay, and which usually located in the edge of the network. Okay, so this device is and the provide the services the end user. Okay, and refer to the edge server. Okay, so this server is called our edge computing edge server, and cloud be the IoT gateway. Okay, or means sometimes it could be the IoT gateway, routers, or micro data center in the mobile network is on the base station. So such type of thing is on the represent as a edge server. Okay, on vehicle and other things. Okay. Now, what is the main advantages of the edge computing? Is that the in between we have the cloud and a cloud and normal user. We have the edge, so which is the ultra low latency. Okay, and saving the energy for the end user. Okay, so user is not directly connected with the cloud, and as well as the scalability. So it's not like they every time they depends on the cloud, they connected with the multiple edges. Okay, so like cost factor will increase, but somehow you are getting the so this type of thing. So in general, we have the cloud computing, whatever you use the in your institute or in your company, which is the cloud. Okay, so you directly access from your server, and which is the cloud. And cloud is basically the create the like this type of you execute your model in the cloud. Okay, so these are the user, any type of user, either in your case the mobile user is a user, tab user is a user. Okay, so here we consider the multiple types of applications. Okay, like we consider the traffic related applications. Okay, CCTV camera related application. Okay, we consider the health related applications. Okay, so all types of the application we basically directly send to the cloud in general. Okay, but here with traditional intelligence, we create the some intelligence concept, which is the we divided the thing direct user directly not connect with the cloud. But whatever we have done till now, okay, so like anything in your institute or in your organization, we basically focus on the cloud computing, and cloud we store everything into the cloud. But here, our objective is we store here we created the edge. So what is the benefit? So this user, this smart watch user, okay, when he want to retrieve some information or something, okay, on this mobile user, so then he's not directly transmit the data to the cloud. Okay, so all this information he can communicate with the edge and getting the whole information. So here, what are the benefits? So whatever the benefit I discussed, it is ultra low latency because it is closer to the your cloud, closer than the cloud. And second thing is that the it is your low energy consumption for the user. Okay, so these are the and scalability. Large number of devices, it is not create the huge number of traffic on the cloud. That's why we created the multiple uses. And it can be your base station, it can be your router, it can be a other type of infrastructure also. Okay, so this is the traditional intelligence. But whatever we discuss, which is the and AI, machine learning, whatever I discussed, so all these devices they have the they want to execute something and they want to use the AI. So here in this figure, they depends on the edge and they depends on the their server. because they want to execute their model into the server or into the cloud. Okay, whatever we have done, like the Google Colab. Also, you execute your code into the server, or in your institute you have the server. So you want to execute the any machine learning algorithm, whatever your application related, which is execute into your server or cloud. Okay, so this is the basically concern in this figure, but we don't want to go with the normal thing. So just in this talk, I will discuss about the edge intelligence, how we create. This is the traditional intelligence. Okay, so we already developed the some solution based on the this edge computing, where we include the additional thing here, additional base station, which is cost factor will increase, but which is reduce the latency, okay, as well as the reduce the energy consumption and increase the scalability. So we same thing we use the in the case of vehicular environment, or in the case of transportation, intelligent transportation system, vehicular ad hoc network based or this vehicular edge computing based transportation. So here, what is the in the vehicle? We day by day increasing the large number of vehicles. Okay, same family have the multiple vehicles. So we realize the vehicle have the with the some connectivity. Okay, so then the vehicles are not every time want to connect with the cloud. So in between they have the edges, and they can connect with the edges for retrieve the some information, some warning messages, or something related to the accident related information, some assistance, such type of thing. Okay, so this so that's why the edge devices we use here for the efficient communication. And because the sometimes the some warning messages, so immediately we want to transmit the other vehicle. Okay, warning message related to the accident or speed profile of the vehicles. So such cases we consider the such type of, so we can directly communicate with the edge, and from the edge we are getting the message easily. Okay, and as well as the energy consumption and scalability also high. Okay, so now we are focusing on the edge intelligence. While the edge computing addresses the critical challenges, AI based application and combination of the edge computing and AI. Okay, so this is the solution which is called the edge intelligence. But in the previous case, normal edge computing only give you the computing thing. Okay, but here we give this one give you the new concept, which is the edge intelligence. Okay, but what is edge intelligence? Okay, so here what is the benefit? We edge intelligence refer to a set of the connected system and devices for the data collection, caching, processing, and analysis of the proximity where the data is collected, and as well as the we also enhance the quality of the data, speed of the data, processing of the data, and also maintain the security privacy of the data. So these are the benefits we are getting if we use the edge intelligence, enhancing the quality and speed of the data processing, and to protect the privacy and security of the data. So these two things is the important to through the edge intelligence. Okay, so this for this purpose we are using the edge intelligence type of concept. Okay, so that's why we have the edge intelligence and in between the user and cloud. Okay, and four fundamental thing in general in the case of edge intelligence, we have the edge caching, edge training, inference, and edge uploading. Okay, so now what type of intelligence we need here? So we have identified, okay, like the sometime, okay, we have the immediate response. We want to execute our model immediately. Sometimes we execute model on the on device, or sometimes, if possible, we can execute our model into the edge. Okay, so edge is more powerful compared to the normal devices. Okay, so then we created the edge type of distributed environment. So there's no dependency on the server, and here we can compute in the all the information into the our edge level. Okay, and same thing here also, we compute the all information to the edge level, and this is the our cloud. Okay, so and in the cloud we execute the some part of the computation cloud. So that's why we don't want to overload the cloud. We execute our all information in the cloud, and which is we are getting the benefit for the prediction. We are getting the benefit for the computation. We are getting the benefit for the latency. We are getting the benefit for the less energy consumption. We are getting the benefit for the scalability. Okay, so that's why this edge intelligence thing is there. So what type of application in the edge intelligence? We have the smart AI vision. Also, we can use the edge intelligence. AI healthcare. Also, we use the edge intelligence type of concept because immediate response is important. Okay, and smart energy application also nowadays, like in the case of energy trading, we also use the edge intelligence concept. Smart factories also we use the this thing, and just I discussed the vehicular cloud edge computing, which is the intelligent transportation system related thing. Okay, then why edge computing? Because edge computing market is there, and the V2V and V2I type of communication we use reduce the network congestion. Okay, because we are not congested the edge means cloud. So that's why massive data from the input and output devices and the real time performance, immediate result is required, and contextual services. Okay, and what is the challenges in the vehicular edge computing is, and the main challenges is on the high mobility. So all the vehicles, okay, if we consider the vehicular edge computing, simple edge computing is something. Now we add the vehicular edge computing. So what is the challenge here? The vehicles are highly dynamic node on the highway or roads, and which is the 80 to 100 km per hour. Then the high mobility due to this, your computation and communication will affect. Okay, so then the performance of the constant environment, then you have the scalability, these are the challenge, and as well as the security. Okay, and resource management and task migration. So these are the in general objective in the case of edge intelligence, any type of real life application, it's scalability, security, mobility, performance, and analytics. Okay. So this is the also the one another model we develop, and where also think the how if the anyone access our data or model related information, so then how this approach will secure the all information. So that's why we use the registration authority and some registration process. Okay, and we use the two type of model: local model, edge model, and the global model. So local model executes all the information related to the vehicles, and this global model is aggregate the information which is in the cloud layer. Okay, so here also the same we use the federated learning type of concept, and where we execute the some of the model into our edge level. Okay, so and security analysis perspective, we use the different types of the attacks. Okay, so like the we give the okay whatever the existing approaches. Okay, so they have protected from the 2 or 3 types of attack. Here we have protected from the 8 types of attacks. Okay, so then our system is whatever we develop, which is the more secure type of concept. Okay, so now where we need the AI and some what is the user case, okay, or somehow the use cases. Okay, so like here whatever I discuss, 2 things I till now discuss. One is the ML, which is the part of AI, and edge computing or edge intelligence. Okay, so how we solve the real life problem. So whatever I discussed, the edge intelligence, machine learning, these are the technology. So, and this technology is in the help us to solve the complex problem. So here we identify the 2 thing is in the more complex thing. Okay, just it is a test case. Okay, it is a very easiest test case. So that's why that just I give you the idea. Okay, so here the test case is 2 things we want to calculate using the AI. One is the driver stress, okay, and driver behavior. Okay, so why we want to calculate the driver stress and driver behavior, which is somehow we solve the solution road safety. So that's why we want the driver stress and driver behavior, because due to the driver stress and due to the driver behavior, there then the some accident occur. So that's why we want to identify such type of driver stress and driver behavior. Okay, so now why it is not why we need the AI or machine learning model type of concept, because it is challenging thing. Okay, like the your stress level is high. Okay, but his behavior is normal. My stress level is medium, but my behavior is abnormal. So such type of complex scenario, okay, it is depends on the, because you have the capability to handle the high stress. I don't have the capability to handle the high stress. So such type of thing is under we can somehow handled through the AI and as well as basically the ML, machine learning, as well as the our edge intelligence. How? So first we collect the data. So this data collection means just a device level, we collect the data. Then here we use the AI. Okay, so like the stress assessment. Okay, then we calculate the behavior thing. Okay, and after that we recommend the, okay, if your behavior is good, so then we recommend him you. If your behavior is average, then we give you the warning information. Means you means not you, like the driver. And if your behavior is not abnormal, then we not recommend you for the next trip or not recommend you to the drive. Okay. So these are the things. Okay. So now my question is, here if we have the single driver, we can calculate this thing. It is easily. But we have the in general n number of driver in our real life application. So that's why the and large number of drivers, and we want the scalable solution. Okay, everyone depends on the cloud, and which is not give you the correct solution. Okay. So and same thing for the data collection. If you want to collect the in the cloud level all the data, so from the device to cloud, update the your model, then which is also challenging. So that's why the edge computing or edge intelligence plays an important role. But we also need the machine learning models. Okay, so machine learning model is calculate the stress, which is difficult thing, and but how this model is under basically responsible for the collect the stress and behavior. Okay, or calculate the stress and behavior. So just I mentioned the we have the input and we are somehow through the model we are getting some predicted output. Okay, so what is the predicted output? So what is the input? Input is in the like different type of information, like the trip related information of the vehicle or driver, weather related information, okay, road condition, road nature, driver data through this input. And we have the not the driver data means not the simple multiple parameter. Trip information means total number of trips he completed. Okay, so means what is the distance of the trips, rest hours. So multiple things we consider. So through these are the features we use the in our model. So these are the input. Okay, we give into the our model. Okay, whatever the model, machine learning model we want to use, whatever the simple model, SBM or logistic regression or any other type of model. Okay, then after that you are getting the, okay, so this thing the output. Okay, what type of output you are getting? So you are getting the output is on the this driver is high stress or medium stress and low stress. Okay, whatever thing you consider the output. Then from that stress we calculate the behavior. Why need the behavior? Sometimes there is a possibility your stress is high but its behavior is normal. Okay, such type of thing. So that's why we estimate the behavior. Again we use the model and then the consider the behavior thing. Okay, so my screen is visible to you?
Yes, are visible now.
Okay. So then they're gone. Okay, so that's fine. So now, so in this case, so then so in this case we have the two machine learning model, whatever model you consider, which is calculate the stress, and second one is the behavior. Okay, this thing and this calculation is for single driver. It is easy. When we need the n number of driver, we have the n number of devices. Then we have the edge intelligence type of concept. Okay, whatever the feature you can consider based on the your understanding. Okay, and which is calculate the stress of a driver. Okay, so here like you consider the distance travel. So distance travel also connected with the stress calculation. Time travel also connected with the okay the completed trips also connected with the age is also connected with your stress. So such type of parameter you can consider in your calculation. Okay, so then you have the data as an input. Then driver wise, you identify the no stress, medium stress, high stress. Okay, same thing. You have the your behavior. So behavior wise, individual driver wise, you identify the behavior. What was the behavior? Behavior is either aggressive, or behavior is drowsy, or behavior is your normal. Okay. So this type of thing we can using the machine learning or whatever the I mentioned the this machine learning training testing type of concept you can calculate, but we need the high computation. Okay, and as well as the immediate response. Okay, so like this thing till now we have done. Okay, so like the we calculated the stress through the parameters and we calculate the stress, no stress, medium stress, high stress, and here drowsy, normal, and aggressive behavior. Now we recommend this thing to the driver. So like if the data we collected and we have the features, then we calculate the stress, then we calculate the behavior. If the behavior is like aggressive, okay, or drowsy, then we don't give him the trip, next trip, okay, and we don't allow him for the next trip. If somehow we have the this thing, the behavior is at the normal, then we give him the this thing, the next trip or accept the this driver for the good based on the stress and behavior calculation. But here also you can modify, you can also give the, in the case of drowsy, you can give him the warning message type of. So you can update the your app or you can update the your program. Okay, so here what type of thing we want to solve? So individual driver wise, we can calculate the our model here. Okay, and here in the in number of vehicles here, so we can calculate here. Okay, all the driver related information because immediate response perspective, same thing. So that's why the edge computing is plays an important role. We don't want to send the all information to the cloud. Okay, so that's why like this way also vehicles are calculated. So this is the edge. Okay, edge intelligence type of concept. So here if you check this in this figure, we have the model. So this model is responsible for calculate the individual vehicle wise stress or individual driver wise stress behavior, and then the recommend these vehicles for the next trip or not. So this is in the edge level. Okay, and as well as the also cloud level, we perform the sum of the tasks. Okay, which is then the global thing. Okay, so that's why the edge intelligence or edge computing plays an important role, because here the all the model and everything we execute into the edge. Some model we executed here, which is the aggregated model type of concept. Okay, same thing we have done here. Driver wise model, then the update the all the informations. Okay, and this is the our cloud type of concepts. Okay, so this is the accuracy level, whatever the model we can, so you can calculate that measure accuracy, whatever the understanding of the. So just I mentioned different type of machine learning model. These are the deep learning model, LSTM type of thing is also used some of the applications. Okay, and as well as the some of the application also use the other thing. Okay, so like okay, so so this is the thing. Okay, so you can use the multiple models. So these are the some deep learning models. Okay, and we calculated the measures. Okay, based on the multitask learning neural network. Okay, as well as the SVM. Okay, and so now we are focusing on the so this type of the edge intelligence concept. we want to use in the generative. So our simple thing is on the machine learning. Then we have the what is the second thing is on the our we have the deep learning, and then the third concept which is the edge intelligence. Okay, where we add the additional concept deep learning concept top of the with the edge, and fourth one is on the generative AI. Now here we integrate the both things. So both thing is on the generative AI and as well as the edge. So now here we created the one environment, or basically the one framework, which is the Edge Intelligent Generated Content, okay, AIGC. So what is the responsibility of this framework, whatever I discussed? So this framework is an automated method for generating, manipulating, and modifying the valuable and diverse data using the AI algorithm creatively. So which is generate, manipulate, modify everything. Okay. Uh, all these things, okay, valuable and diverse data using the your algorithm. Okay. So which is the collaborative edge intelligence, or sometimes it is called the edge cloud mobile, or sometimes the edge intelligence, this thing. Okay. And what is the benefit? We can implement such type of platform. We provide the security, efficiency, privacy, all type of information. Okay. And here, our framework, whatever the framework we develop, so whatever I discussed, we have the framework is edge intelligence based framework, means the framework is basically give you the device level, edge level, and cloud level. And this framework is whatever I in the test case I discussed, so which is the data collection, okay, pre-training, fine-tuning, inferences, okay, product management, all type of activity we have to do. Okay. So here, if you check, here we have the thing. Okay, so this is and the first our objective is and the our data collection. Okay, after the data collection, we have the so we data collect from the environment. Okay, so we can collect the data from the IoT data collection. We can data collect from the data market, crowdsourcing. Okay, and as well as the we have the pre-trained model. Okay, so this pre-trained network. Okay, where we trained the our data. Okay, after that we have the different types of fine tuning. Okay, so different parameter, hyperparameter changing, loss function changing. Okay, model changing. Okay, and feature selection also changing. So then we have the this inference. Okay, so this inference we have the two types of the inference, server inference, and we have the device inference. Okay, then after that we have the what type of product, so product management type of concern. Okay, so this type of but in this type of platform we have the three types of concept. One is in the algorithm, one is application, third one is edge intelligence. So whatever the literature and whatever the till now product, product means three type of thing. Okay, one is hardware related product, software related product, and your service related product. So this product is either focus on the algorithm or focus on the application. Okay, or combination of the two, some of the cases. Okay, no one consider the all the these three. So that's why we want to consider the all these three. Okay, type of the algorithm. We also focus on the application and focus on the edge intelligence. Okay, so now in our edge intelligence, top of the edge intelligence, we have the generative AI. So generative AI, what is the concept? So concept is another till now whatever I discussed, which is the focus on the this AI concept. Okay, so AI generated content, then the data collection thing is there, pre-training thing is there, fine tuning, and then the but what type of model? Whatever the model I discussed, like the SBM and your decision tree, random first, these are the machine learning model. Then again, I discussed the some of the model, which is the LSTM, DNN, deep neural network. These are the our deep learning models. But here, when we focus on the algorithm, application, and edge intelligence, so our model is generative AI model. Okay, so what are the generative AI model? Okay, which type of model we use for the generative AI perspectives? Okay, so in this case, our generative AI and what is our main contribution? Our main contribution is on the low latency, okay, privacy security, Okay, as well as the mobility also we can include. Okay, and as well as we consider the multimodal data, automatic thing. Okay, so these are the generative AI model we can use for our applications. Okay, so this is the main concern of the our talk. Okay, so that's why. And other thing also we can include, but we don't want to discuss the all this thing. Okay, we want to discuss so GAN. Okay, VAE, age-based model, diffusion-based model, flow-based model. These are the generative model we can use for our applications. Okay, so like initially we use the which type of model? We are getting the some accuracy, whatever I discussed. Okay, in the case of machine learning model, then enhance the accuracy, we use the concept of this thing, a concept of the deep learning model. Then we add the age intelligence, then again we enhance accuracy and output both. Okay. Then after the top of this age intelligence, we want to add the concept of only generative model is there, which is give you the better visibility, better output. Then top of this, we use also include the collaborative infrastructure like edge for cloud or okay, edge for cloud or somehow the edge mobile network. And then we have the different type of the metrics like the precision, recall, quality of experience, new type of measure also we can do. So this is the our concern. And what is the whole life cycle is just I mentioned data collection, pre-training, inference, fine tuning, and product management. Okay, what I discussed. Okay, so this is the in general concern. So ChatGPT is under our generative thing. Okay, which include the pre-training, fine tuning, inference, and product management. If you check the same thing happened here. Okay, so which is the your data thing is there. Then the we pre-train this thing. Then we have the fine tune. Okay, what are the fine tune? Just I mentioned the supervised policy based on the collected demonstration data. We tune the or train our reward model. Okay, all these things you can do, and then finally you have the your product. Okay, so Microsoft also use the product. Okay, and as well as the other companies also use the similar type of product for the this. Okay, and these are the model generative adversarial network, just I mentioned. Then the bidirectional autoencoder VAE, okay, which is the most popular thing nowadays. Everyone want to use this thing. Then other than this, you also use the, but all these model, if you check the architecture, is more or less similar. Okay, so this type of model give you the, but with the concept of edge intelligence. Okay, and these are the traditional generative AI model. Then you tune the your different parameters. Okay, so here whatever we discuss this thing is on the like edge intelligence. Okay, and as well as the basically focusing on the mobile AI based generative content network. Okay, and these are the thing. Our objective is the edge layer. So which is the basically our concern is basically the concern is geo distribution, low latency, and customization. Okay, then other thing we have this type of concept also we can focus, but we are more focusing on the edge layer, edge intelligence, and limitation is quality, capacity, and security. So that's why we use the federated line type of concept. Okay, then maintain the high level of the security or privacy preserving concept. Okay, same multiple driving simulator also use the AI generative AI concept. Okay, for the understand the behavior of the drivers. Okay, behavior of the pattern of the driver. So this is a simulator. Okay, but whatever we discuss in our case, driver behavior where we use the not only the thing, we also use the explanation and all those type of things. Okay. So same thing for the, we can use this thing for the real life application for the image also resolutions. Okay. Then we have the quantum edge computing, which is the advanced topic, top of the generative AI and edge intelligence. So why we use the quantum edge computing? Just I mentioned that in the real life, we have the edge this thing is on the main challenges with the latency, scalability, and security. So quantum computing give you the computing platform, edge computing give you the your security reliability type of thing, and the cloud computing give you the computing and storage type of thing. Okay, so that's why that these three thing. So what are the address these challenges? Okay, reducing the latency, improve the scalability, and enhance the security. Okay, so these three things is under quantum edge computing give you other benefit. Integrating the quantum cryptography to enhance the integrity, using the cloud computing resources, so then the support the large number of IT network. Okay, so here this is the quantum thing, hybrid quantum computing model we we already developed. Okay, so here we have the in the previous thing, if we remove the right part, okay, in the left part, if we focus, so if you check, we have the classical computer, classical edge node, and we have the IoT devices. So till now, we focus on the this type of nodes communicate with the edge, which is the for the efficiency, whatever I mentioned, low latency, less energy consumption, such type of thing, and classical data center. But now we created the quantum edge. Here we perform the some quantum computing, quantum communication, and quantum security type of quantum post-quantum cryptography type of concept. Okay, so while the our traditional security algorithm, all those things is not suitable. Okay, so that's why the here we have added our infrastructure, which is called the hybrid infrastructure, where we have the quantum edge networks. Okay, so this is the benefit for our network where we have the future hybrid quantum concept, and where which the quantum computing node can be placed in the case of edge network, and which is closer to the data source and Internet of the Things devices. Okay, so which is the getting the more benefit. Okay, and advanced quantum hardware development as well as the quantum error correction technique is also we can implement in these areas. Okay, so in this area you have the lots of opportunities. You can lots of AI engineer or software engineer, security engineer, crypt analysis, data analysis, data scientist, security consultant, all this type of CS related or computer science or AI related job, you have the opportunities. You can do the higher degree. These are the all the universities. Computer science, you can do the master program, undergraduate as well as the PhD program or postdoc. All those universities they also offer the generative AI or edge intelligence related some specialization. Okay. Other than this thing, you also focus on the these are the other areas: blockchain, role of AI, smart grid, 5G, future network, Internet of Things, quantum computing and communications. And all these cases, you have to have the some basic concern. It's not needed the, all this. At least you have to have the some programming understanding, either C or C++ or Java or Python. Not like the all this. At least if you have the Python, then which is good because large number of packages and AI models. Okay, you can implement through the Python. So at least you have to have the some idea about the Python. And second is then the data structure. These two things is enough for the compulsory for the this AI, machine learning, deep learning type of concepts. Okay, so these are the things. Okay, other than this, you have the other subjects like the database. Okay, and the operating system and algorithm and networks. Okay, so these are the things. Okay, for this and IIT Jodhpur, we have the multiple undergraduate internship. Okay, so if you are teacher, so your institute also large number of BTech undergraduate as well as the postgraduate and PhD also we offer the multiple internship, and the online forms are available, which is the rolling advertisement. So any student, any faculty also, if they are interested to the joint research. So we have the this thing, and also we provide the these are the rules. Okay, but we also provide the better fellowship for the undergraduate students. Okay, so these are the thing. And other than this, so if you have that any question, any query, then I will be happy to answer this query. Thank you.
Okay, participants, you can raise your hand so that we can unmute yourself. Anyone who wants to ask any queries? Okay, just 2 minutes. Yeah, Dr. Pradeep, you can unmute yourself.
Uh, Good evening, sir. Good evening, ma'am.
Yes, good evening.
Yes, I just wanted to ask that what are the opportunities for postdoc in IIT Jodhpur, if there are any
Here we
courses
have the,
there?
yes, we have the online portal, okay, rolling portal. So you can submit your application and you also
Okay.
identify the area and you submit your SOP, statement of purpose, means statement of the research. Okay, which area you want to do your research. And we also provide
Okay.
the good fellowship. Okay, some fellowship is and the means better than the other institute also. Okay, some special scheme also there. Okay, as well as the normal postdoc fellowship is also there.
Okay. Can you tell what is the average remuneration if there is any?
Means around 80 to 1 lakh, 80,000 to 1 lakh per
Okay.
month. Okay. But you have the good research background as well as you have the some expertise because you have to do the this postdoc. And sometimes the some industry postdoc also we have then which is the better than the institute, then they provide the better this your fellowship.
Okay. Okay. Just wanted to know that whether edge computing is utilized in India till now or not.
Yes, it's everywhere when multiple applications like the some of the applications like the all the traffic management. Okay, in the some of the A1 cities like the Delhi as well as the Bangalore, they use the edge computing and sometimes the drone based communication also that they use the drone as a edge devices. Okay, some
Mm-hmm.
safety critical applications. Okay, so Edge is and nowadays as well as like Jackson, basically NVIDIA company basically offer the Edge devices as well as the Intel now means develop the develop the Edge devices. Okay, so Intel NU and NVIDIA Jackson. So all the companies everywhere and all the nowadays the other different organization and different application like the surveillance applications. Okay, as well as the port management. Okay, and in the airport also we use the edge devices.
Okay. Thank you, sir.
And they also use the edge intelligence concept. Okay, but not like this high level intelligence model. They use some basic machine learning model or some decision making type of thing.
Okay, any more queries? Participants, please raise your hands in case of queries so that we can unmute you. Okay, Vijaya, I think you have given, Vijaya Balapande, we have given you the mic. Please go ahead.
Good evening, sir. Am I audible? Hello.
You're audible.
Yes, you are right. Yes,
So, for the jet engines,
yes,
if I want to apply an algorithm for
yes,
reduction of a noise,
yes.
so what kind of algorithm I should go for?
No, but jet engine first you have to have the data. No? So which
Yeah, yeah.
type of data you have? So which is label data, unlabeled data, sensor data, image data. Then you check the which algorithm is more suitable for you.
I'll be having the parameters like velocity, speed,
Yes, so then text data. So
whether
any model.
RPM.
Yes, so then text data. So then the any type of either deep learning model or machine learning model you can use. So like nowadays the most popular model deep learning. If you have the such type of computation environment, then you can use the LSTM type of model or basically the transformer type of model.
Okay, sir. Thank you.
Okay.
Okay, next participant, I think raise the hand. You can unmute yourself. You are unmuted.
Hello.
Yes, sir, you're
Hello?
audible,
Yes,
please.
yes, yes, you are.
Yeah, good evening, sir.
Yes. Good evening.
Yeah. AI is the challenging is a topic, but thing is, what about the job opportunities, sir? Everyone is saying there is a lack of jobs in the AI field. Okay, but okay, AI is the current technology, but there is no specific jobs in India.
No, no, it's
And what
a
about the
large
future,
number
sir?
of large number of jobs here in India, but skill worker is not there. Okay, skill worker means like some company want to like they why they hire the undergraduate and postgraduate student because they somehow develop some solution. It's not like that they only execute the whatever the existing model is available only those models. Okay,
Okay.
like if they deploy them, they can create from the existing model. Okay, whatever they have the some idea and they can create the new model or they can
Okay.
modify the existing model. Such type of jobs are there. In the IIT Jodhpur till now, our 70 around 70% student placed. Okay, and around average package 40 lakhs plus. Okay,
Okay.
okay, so all this large number of companies from the AI companies. Like this time also Microsoft offered the job in the AI and they also provide around 70 plus package.
Okay,
Okay.
suppose in the future, all missions and equipments and all robots, they are equipped with AI, then what about the future?
Future is
Suppose,
and the like somehow when you have the something some of the technology then also the some skill worker is required for handle those technology. Okay, so then your job opportunities also increase. Okay,
okay,
but in this case you have to have the knowledge. It's not like the just only thing. Okay, so you have to have the some knowledge. Okay, so the problem is nowadays everyone your AI model code is available in the online. Okay,
yes, yes,
your
yeah,
data set is available. Student also don't want to understand the code. They only execute the code and they are happy. Okay,
okay,
such type of thing is not. If they understand this thing, then large number of job. Okay, now it's startup company also offer the huge packages.
okay,
Okay,
right,
so yeah, but somehow skill. So that's why I mentioned the skill thing is important. Okay, you learn from the your textbook, you create your skill, then you can create you can use your utilize your intelligence.
right, yeah, skilled persons only will get the jobs in AI.
Job in this area. Yes, because in the AI job, other job you have the other options. This is a separate thing. Okay, but in this AI field you have to have the skill. Okay, like you at least you like today your problem is related to the Parkinson detection or cancer cell. Okay, cancer type of disease detection. Okay, so you develop the some model and which is predict the your cancer or which is predict your Parkinson. Okay, some one model is Parkinson, one model is cancer. But if the COVID is there, COVID 25, so then those models are not working. You develop the new model. Your data is also different. So then such type of knowledge you have, your understanding. So you can create you have the existing idea. You already developed the model for Parkinson. You already developed the model for your cancer. So that's why you have the capability to develop the model for whatever you have. So
Okay,
in this case, so such type of things are there. So that nowadays also we are getting the large number of industry project, sponsored project in the area of AI because no one have the enough knowledge. Okay. So if the some student have the knowledge, some faculty have the knowledge, then which is sufficient.
how the government is taking the policies to enhance these knowledge to the students or faculty?
Yes, so
Okay,
government
this is
also
okay. This
yes,
is yeah.
yes.
This is one process, online FDP and like that. Okay, but theoretically we'll understood the few topics only, but practically how will get the exposure?
Yes, so that's why the government want to like create the one ID for individual students. Okay, And through this ID, they can access the all real life application, everything in the government portal. So government want to create the one portal by next year. Okay, with the help of the Ministry of Home Affairs, because here the the some ethical thing and all these things are there. So government and as well as the AICT also involved with this. Okay, they want to create the some thing and where you have the all the AI related code, everything you can develop your skill, all this information you can, but like the other type of ID for a student.
Okay. Thank you, sir.
Okay.
Okay, any other participant who wants to ask question, please raise your hand. Yeah, Vivina, just 2 minutes. Yes, your mic is now enabled. Vina, madam, you can unmute yourself.
Yeah, hello. Good evening, sir.
Good evening.
Sir, I've just started my research in machine learning area. As I just wanted to know that how do you get a hands-on experience in an area which is very new to us? Like sir previously who asked the question, we get the theoretical knowledge, but when practical aspects come into picture, we just hear about fellow researchers who have done research. But is there any program by IIT
Yes,
Jodhpur that can provide us some hands-on experiences?
like we have the some 7 to 10 days training program. Okay,
Okay.
where basically this it is offered by the just in the second or third slide I discussed now we have the JCKIF or
Yeah,
TISC
yeah,
type of
yes,
company.
yes,
So those
yes.
companies basically offer this program. So you can check. Okay, their thing. Okay, so they basically offer the 7 days. Last time also, like from Pune, as well as from Maharashtra, as well as from Bangalore, multiple student group. Okay, so they group wise they conduct this thing, 7 days program, and they charge
Okay,
the minimal charges, and they also
okay,
provide the accommodation, all those things. And I am also taking the some class, but this classes is hands on.
all
Okay,
right.
like I give you the like this, whatever I mentioned, the stress and behavior calculation. So how you
Yes,
write the code for stress calculation from scratch.
right,
Okay.
exactly.
Okay, so such type of thing we have the such type of training, but those companies basically offer and IIT professor basically conduct the hands-on session. Okay, as well as some company people also, industry people also conduct the hands-on session.
So how do we apply for this, sir?
You can directly go there and you check the training program or somehow they mention the what is this? This is most for internship. They mention the 10 days
Yeah,
internship
an
type of thing.
internship.
Okay.
Yeah, yes.
Yes. Okay, so you can
Oh,
apply those things. Okay, as well as like in our lab also we offer the 1 month to 6 month internship. Where also we use basically in our lab basically we offer the different problem statement and based on the problem statement different type of your solution. Okay, like real life solution, hands-on solution. Like we are working with the multiple project of the ministry as well as international
yeah.
project. Okay, so some of the module, not the all detailed project. Some of the module I'll give you, and I'll give you the how the hands-on thing, so you can think the how you improve the this module. Okay, based on the intelligent algorithm or AI algorithm. Okay, currently we are working with the Alzheimer disease prediction. Okay,
Okay,
using the wearable or a smartwatch. Okay, so our
all right.
objective is using the digital biomarker, means like the wearable devices, we have the less number of parameters, but we develop the intelligent model, which will give you the high level of decision making.
Accuracy. Yes. Okay,
Okay,
sir. Okay. Thank you
okay,
so much, sir.
okay.
Okay, any other queries? So I think there are no queries right now. So I request Dr. Satyabrata Singha sir to propose the vote of thanks.
Yeah, yeah. Am I audible?
Yes, sir, you're audible.
Yeah. Good evening, all the participants here and the speaker, Dr. Devas sir. On behalf of the organizing committee of AICT sponsored 6 days online FTP on quantum AI and quantum computing, the future of intelligent systems, I take this opportunity to express our heartfelt gratitude to Dr. Debasis Das for delivering such an insightful and engaging session on generative AI with edge intelligence during the first session of the second day. Dr. Devashish sir, your profound knowledge, innovative ideas, and practical insights have truly enlightened us on how generative AI can be effectively integrated with edge intelligence to build smarter, decentralized systems. Your explanations on the challenges, advancements, and applications in this domain have provided all the participants with a fresh perspective and deeper understanding of this cutting-edge field. We deeply appreciate the time and effort you have dedicated to share your expertise with us. Your session has undoubtedly enriched this FDP and inspired us to further explore and apply these concepts in our research and teaching practices. Once again, thank you, Dr. Devashish Das, sir, for being a part of this program and for making this session so productive and memorable. We look forward to more such interactions in the future. Thank you all. We will be starting the next session shortly by Dr. Sitaram Therapati, sir. Yeah, over to you, Papia, madam.
Thank you, sir. So our
Thank you.
next resource person has already arrived. That is Mr. Sitaram Tarepalli, sir. I'll just give a brief detail about sir. Mr. Sitaram, sir, is a seasoned technology leader with over 18 years of experience in innovation, evangelization, solution designing, and strategic development. He currently serves as the Vice President of Machine Learning Engineering at DBS Bank, where he leads the machine learning platform team. Mr. Sitaram is responsible for developing and implementing a comprehensive suite of products that cater to every aspect of machine learning lifecycle management. These products range from AI protocol and governance, model training and experimentation, batch and rest deployment tooling, feature transformation tooling, monitoring, and explainability. His area of focus is the field of machine learning, ML ops, enterprise AI model governance, responsible AI framework, and enterprise grade feature store solution. He is actively involved in the industry, serving as a senior member of the IEEE and life member of the Cloud Computing Innovation Council of India. He also acts as chair for Technology, Engineering and Management Society IEEE Hyderabad section. Mr. Sitaram holds a bachelor's degree in electrical and electronics engineering from Jawaharlal Nehru Technical University and a master's degree in data analytics from BITS Pilani, Hyderabad. He is currently pursuing his PG program from IIIT Hyderabad in Privacy, Fairness and Ethics in AI. So over to you, sir.
Thank you for the introduction, ma'am. Let me come on camera. Hope you can see me, and it gives a very personal touch. I'll share my screen. Just a second. Give me a second. Are you guys able to hear me?
Yes, sir, you're audible. Screen is sharing is still pending. I think that you're out of the network, maybe. I don't know, because we are not able to hear you. Yeah, audience, please be on hold. The resource person is having some connectivity issue. It's joining once again.
Hello, Dr. Papia. Are you able to hear me?
Yes, sir. Now we are able to hear you. Can you just share your screen also so that we can check it?
Apologies, some glitch.
Yeah, I think now it's getting connected. Your screen is visible now.
Okay, how about the presentation?
Yes, yes. Now presentation is visible. I think slideshow mode is required just.
Yes. All right. Sorry for the technical glitch. And thank you for waiting. My name is Sitaram Tadepalli, and I work with a company called as DBS Bank. We are a large Singaporean bank, and we operate out of Singapore, China, Thailand, Taiwan, India also, Indonesia, and other countries. Uh, and I lead the ML engineering group for DBS. So, and thank you, Dr. Papia, for asking me to come here and deliver this lecture. I will take probably around an hour and a half, kind of a thing. And I was hearing Dr. Debashish talking on generative AI and especially on the edge. So probably my topic would be a more industry-oriented version of what we are going to what we are doing in AI. So to give that perspective, and I also have another more technical topic which is going to happen on Saturday. So I hope if you like this session, you will also continue hearing me on the technical topic. So with that, we can go ahead. If you have any questions, I'm not sure if you have the chat window or something. Probably put them on the chat window, and then I'll answer those questions at the later point. But predominantly the session will be going on in more of a practical approach of how we are applying areas AI in different areas. I will walk you through different application areas where we are using AI in real world, and that should give you a real glimpse. Now, the question about this AI, data analysis, machine learning, and all these terms, while they are being used right now, but it is being used for a very long time. This is not a new term. People who are collecting data, even dated back to 500,000 years back, also we used to have a lot of data and database analysis used to happen, right? And there were a lot of theories which emerged early 19th century on how the data collection needs to be done. How do you do business intelligence? How do you conduct experiments? How do you do exploratory data analysis and all that stuff? And AI as a term also was coined very long, right? So you all might already know. So this is not a new term, but there are a couple of things which changed over these past few years. I would say, especially the past 10 years has been very revolutionized the way AI is using. The three important things which changed in the past 10 years, I would say, is the way in which we store data, the way in which we have created compute capabilities, and the third one is the way in which algorithms are evolved over the time, right? Because of these three important things, there was a lot of work happened. I'll go through a little history of it, and then eventually we'll look into like how this all happened. So to understand these terms, of course, by now you might already know AI, machine learning, deep learning. I might not spend a too much detail on this particular slide, but eventually it started as if like AI wanted to replace humans, where we do a lot of automated tasks. So humans used to do a lot of manual tasks. Like initially when AI was coined, it was thought that how we can change that manual tasks into a much more automated way where computers can do the control of the work. So that was the initial thought, and many of those kind of logical applications came to picture. Some of the technologies which are used to automate some of the manual tasks, which can be done by computers. So primarily the focus was that. Then came machine learning, where those automated tasks which are logic based, if then else condition based, and so on, were not being handled because the data was growing. When the huge amount of data was growing, we need to take help of algorithms which can help to condense the data, use some statistical techniques, and make sense of the data. So that was the era in which machine learning was very prevalent. Then came deep learning, where data was not in a single standard format. It was purely not in a structured format. There were other types of formats. I will also show you some of the examples and like what different types of formats are used. So things like speech or image recognition or similar kind of things are gathered, and in such kind of data formats, we were we were able to create more condensed neural network based architectures which will make sense of even the unstructured kind of data. Now we are in the era of generative AI, and the past speaker have already spoken about a little bit on that. So, generative AI, where we are trying to see, like, again, in the unstructured multimodal format, where we have text, images, and other kind of formats, where we are also able to generate some kind of information. We are not just in the predictive phase, but we are also in the generative phase, where we can either extract some kind of meaningful information and or make some kind of outcomes out of it. In the next year, we are going to go into a phase called as agentic AI. It is already picking up. Even in my company, we are doing a lot of work on agentic AI. So agentic AI is where now these generative AI applications are connected together, where they are treated as agents, and then agents talk with each other and come up with some kind of outcomes. I'll take those examples as we go deeper into the today's session, but just think that how the things have changed over time. Artificial intelligence, machine learning, deep learning, generative AI, and now agentic AI. So all those things are evolving over the time, and there's a lot of work which we are going to get in the future. So this is a significant slide which talked about something called as AI winters. Now we are exactly in this particular phase of a hype cycle, where people are thinking that now there are a couple of AI winters which happened in the past, around 1975s, 1990s, 2000s, where the first two AI winters were caused because of unavailability of data, and the second AI winter caused because of unavailability of compute. So we didn't had enough amount of data to do a lot of AI algorithms, show some proof, and so on. So the first AI winter came because of that, and the second one was we were having data, but you didn't had the enough compute capabilities to run algorithms and get some meaningful ROI of your analysis. So these two challenges caused the first two AI winters, but the current phase we are in, where in 2024-25 would say, where we are seeing the hype cycle of generative AI, we are seeing the hype cycle of agentic AI. People have the same question, that is it a bubble, will it burst, or is it going to sustain for a longer duration? Now, I would say, with my experience, is that this is going to sustain for a longer period of time. The reason is the three areas which I told, which is contributing for a huge surge in adaptability. The first one is the huge volumes of data we are able to gather. The second one is the amount of compute capabilities. Thanks to cloud computing, now we have infinite compute capabilities also available, because we have cloud infrastructures, Google Cloud or AWS Cloud or Microsoft Azure. So these cloud infrastructures are providing us ability to within few seconds we can spin multiple servers at the same time, and able to run a large volume of compute capabilities. And the third one, if you see, what's happening is there are a lot of algorithms which are being open sourced. A lot of adoption is happening in the AI space. So all these best algorithms are being used in and then open sourced and being available to the mass market, so everybody can directly use those algorithms and run their analysis, right? So because of all these three things, we are confidently saying that we are not in a hype cycle, but we are going to sustain for a longer duration of time. So data is the one which is the key component of it. It is growing at a petabyte scale and all, and being available for mass market, so that we can use the data and do a lot of database processing. Now let us take more practical examples of what types of these data are there. If you ask me, in my bank, predominantly the data which is used is the transactional data. So transactional data, as we know, it is the type of data where we are doing a regular day-to-day transactions. For example, I go withdraw money, I go deposit, I open a checking account, or I take a loan. All this information becomes transactions and typically stored in RDBMS based databases. If you take any other business, predominantly most of the brick and mortar businesses has these transactional data in nature. We are trying to do a lot of these algorithmic process using the transactional data, and most of the ROI is coming from here. Now, people say that there is a lot of generative AI hype and all, but when you see where is the money coming from, is from this classical machine learning algorithms, the ones which are able to predict your credit score, the ones which are able to tell us whether I can upgrade a credit card or not, should I give a loan or not. For example, these are some of the core decisions which a business requires. So most of these decisions are being responsible for giving a lot of ROI on the investment which the companies are doing. So traditional machine learning, what we call, is still doing a lot of chunk of business for these enterprises, and they are predominantly working on transactional data. Another type of data, we are getting a lot of these audio and experimental data. Now you see, future is going to be something we call it as no UI. That means that we might not interact with either buttons or kind of devices and so on, but we will be getting into a phase where we will be just talking, right? We already have that glimpse that, for example, I can switch on my television, I can give commands to the lights or fans and so on, which get operated on my voice. Amazon Alexa is one such example, where we are trying to see like all these voice based commands can be used, and all those voice based command can be used for driving a lot of actions. And edge-based computing is much more prevalent, where a lot of these kind of computations happen at the edge on the devices, and a lot of work happens. Another important kind of data is experimental data. Experimental data is in such a way that a lot of these companies, for example, work on oceanic research or maybe on the medical sciences, and doing a lot of experimental related to health and environment and so on. All of them collect a lot of these experimental data, and using the experimental data, we do a lot of predictions like what's going to happen. And if you see, the lot of analysis which happened on COVID-19 vaccine and all were actually the outcomes of these experimental data analysis. Another interesting use cases we are seeing, especially like with a lot of adoption of generative AI multimodal analysis, is on the video and image data. A lot of video content is being generated. I'm sure you might be aware of OpenAI Sora. It got recently released, where if you have an access to OpenAI's ChatGPT Plus account, you should be able to use the Sora, and it helps us to generate videos when we give a text-based prompt. Right, you are kind of imagining certain things, and you can give a text-based prompt, and it can generate videos. The primary source of that is we have a lot of video content already available for Sora, which it can consume, and from the video patterns, it can generate new video. The way we are uploading data to YouTube, the way we are uploading images and videos to Instagram, all these are our sources of data where we are putting onto either public or one of the private clouds. But that data is being used, and huge volumes of content is available. And using that huge volumes of content, for example, Meta, right, it is able to create Llama models. The reasoning is that it has so much volumes of video and text data from Instagram, and all that data is now condensed, and we are able to create models out of it. And the future is going to be with this kind of data. Another like data types like charts and stats and graphs. So these are other kind of data which is predominantly in the business sense that we use this day in and day out. But getting to a little taking a step back, right? What's happening if you have closely observe or do a research on how these technologies are evolving over the years, right? We are seeing that there are these social media analytics companies, I would call. These are pioneers in bringing technologies. If you take like 10 years back, we got big data and all this stuff, and all those core technologies which were brought were from these social media analytics companies. Even now, if you see large volumes of LLM models are also being sourced by these companies, and they have become pioneers in which they revolutionize the technology. The reasoning is that their problems were completely different from the other companies. Regular brick and mortar companies were predominantly working on more of structured data, where you have rows and columns and so on, and I can work on this rows and columns kind of a data. But these companies are having tougher problems. For example, Netflix wanted to recommend movies or kind of similar kind of patterns. YouTube wanted to analyze the length of the video content consumed, and which videos need to be monetized or given higher ad revenues and so on. For example, Instagram's recommending kind of related contents to other users. The reason these companies were different is because they had these multimodal data sources. They had these videos, text, and images, and all these things were very difficult to process. And that's the reason you see that a lot of these new algorithms were generated out of these companies, and then fed to be an open source, and other companies quickly adopted them to put into their businesses. One of the early adopters of AI and analytics is in the phases of something called as predictive analytics. If you think like the companies like banks or insurances, they are the ones which are using this heavily. Even in retail giants, most of these companies are using this heavily. The reasoning is because we want to make business out of this AI, and the only way we can make it is like, can we remove a lot of manual toil and can introduce the algorithm which can do this, which can have this predictive kind of a nature. The predictive analytics comes where I want to predict whether the customer has to be given loan or not. Now there are a lot of parameters which can guide me to the decision, whether the customer is having bank balance, enough kind of liabilities, whether the customer is married or not, do they have children, and all that stuff. See, all these parameters becomes input feed for my model, so it can look at the past history of similar kind of transactions, and can come up with a prediction outcome for the given customer, and do a prediction whether I should give a loan or not. So all these kind of algorithms, the early adopters, which gave a lot of revenue for companies, is falling into this predictive analytics category, where we are trying to predict like what's going to happen in the future, or what is going to happen for a given set of data points. So you can name it like your retail companies, banks, and insurances. These are the ones which are early adopters for these kind of analytics, and used it very well to reap a lot of benefits. Next set of analysis, it came into something called as fraud and intruder detection categories. Now this again, in our bank we have lot of fraud and intruder detection models. Basically we use them to determine whether any transaction is an outlier, whether it doesn't comply to a regular pattern. And in such cases we can determine a lot of difference between your traditional transactions and these outlier transactions, and we can segregate them separately, and there is a separate process which happens, where either an email is sent, or you can have a direct call to the customers stating that we do see that there is this there is this separate transactions which happened on your credit card. Can you confirm whether it is you or not? You might have already got calls saying that, press one if you authenticate the transaction, press two if you have not done the transaction, and so on. And all those things are because of these fraud models. So what we do is we can do a lot of analysis, fraud detection analysis. We do a lot of outlier identification, probe identification, intruder identification. So based on all these kind of pattern models, we can determine whether a particular transaction is separate from the regular group, right? In such kind of cases, we have automated. In the previous years, we used to send the list to the certain banks, and they used to take the transaction and do a manual calling. But nowadays you see that there is complete automation in place. You get an automated messages, you get an automated calls. Sometimes we also go to an extent where we can block the card. For example, your card is in India, you're regularly doing transactions in India, but suddenly you see a car transactions happening in say US. Maybe you might have traveled to US, but if you have not informed the bank, then based on your past history and all, we do automated systems in which they can also block the card to avoid any fraudulent transactions on your account. Another interesting area, we have done a lot of projects in this segment, and even a lot of college students have done a lot of projects in this area where we are trying to find out sentiments of the customers and reviews, because the adoption of a lot of social media, right? Reviews have become so important. I remember like in 2010, when we did the first kind of sentiment analysis models, we used to have for one of the client, we used to have something called as voice of the customer portal. Now, voice of the customer portal, what it does is, based on the experience of the user, they'll go and type their experience. This was for one of the largest car rental company, and in that portal you can go and write your experience, like how was your car journey, how was your rental experience, how was the rental agent, and all that stuff. And then based on that, they used to analyze the sentiment of the feedback, and they used to give like positive, negative, such kind of analysis used to be done. Back in those days, that was very, very important, because I want to analyze, like, for all my rental locations, what is my sense of the customer, whether they are happy, how is the satisfaction index. So we used to compute all these feedback sentiment, and then used to compute the satisfaction index for different rental locations. But fast forward, currently, with the adoption of a lot of these generative AI techniques and a lot of LLM based techniques, we are also getting into a more of entity level analysis, right? So we can do as much granular analysis as possible, which can help us to determine whether a particular product is good or not. If a particular product is not good, why is it not good, what is the particular feature in the product is bad, and all that stuff, right? So you might have to go through a lot of these reviews and then come up with a conclusion saying that this product is suitable or not. But with LLMs and generative AI, what we are doing right now is we can summarize all that content. You can go through thousands of those reviews and come up with a summary. I'm not sure if you guys are aware. If you go to any of the product reviews, or maybe you go to say like Zomato or Swiggy and things like that, or you can go to any dining restaurants or any of those portals, you would see that based on all the reviews, an AI generated summary is generated. Now it says that in this particular restaurant, your chicken biryani is good, and they have given very good feedback on, say, like, pizza or any of those specific type of dishes or specific type of desserts, right? You get all these summarized things. The way it was generated now is because of LLMs. We can condense all that information and then come up with a more summarized version. It takes away a lot of analysis time. Self-driving cars is another very interesting applications which we are seeing, which AI has evolved over time. Uh, if you have asked like 20 years back, 30 years back, if we can have a thought of thinking that a car will drive by itself, people would have called us like fools, right? If 50 years back, if 50 or 100 years back, if you would have thought that I will be sitting in Hyderabad, and there will be 200 other people sitting at different parts of India and listening to me, or probably looking at me, right? If I would have told 100 years back, people would have thought that I'm a fool, right? So the question many people ask is that because now AI is coming, and it will eat up jobs, and will not have jobs and things like that. What I would say is that uh, human intelligence is far ahead, or far more capable of doing a lot of things, and uh, we have not solved a lot of major problems which are humans can do, right? For example, if I have a thought that in a bank, right, I don't have to go to a bank, I don't have to operate on a mobile, but if I think that I will send 100 rupees to Dr. Papia, the 100 rupees should transfer. Now this is my thought. Okay, can I create this kind of a system, right? So humans are evolving and going to a phase in technology where we are trying to solve even more better and bigger problems, right? It can be on climate change, it can be on like making our lives more comfortable, more faster. For example, if I want to go from here to US, then if I go by a flight, probably it will take like say 14 hours, 15 hours, and so on. But can I go in an hour, right? That is not possible at this time. But probably 50 years down the line, it will be possible. So what I'm saying is, AI is helping us to do a lot of things better. AI is reducing a lot of manual toil. Probably there will be some kind of jobs which are very monotonous, uh, which are very manual kind of nature. They will go away, but instead of them, there will be a lot more creative jobs which will be generated. Lot more advanced jobs will be generated, and human race will be working towards those jobs, right? So think the example of self-driving cars, right? We 10 years back, 20 years back, we didn't think that the car will drive by itself, but now it is driving. Now if I think that self-driving car in an Indian local town, which is where it is seeing all the pedestrians walking, cars, autos, rickshaws, bikes, all of them going in a chaos manner, can it drive? If somebody asks me, we can say like it is difficult, but probably 2 years down the line, probably 1 year down the line, we will be seeing a lot of automated cars driving in Indian conditions and can getting adopted to it. And that is where the technology is also going, and we will see a lot of those things which is happening in the future. Another AI applications, we are doing a lot of work in this classification clustering technologies. This is where our meat of AI work, we call it as classical machine learning, where a lot of these algorithms are running in production right now, which will help us to do classify certain cases. For example, I was talking about a very simple example of whether I can give a loan or not, right? Based on a lot of parameters of my customer, I can evaluate the customer on say 100 different parameters, and giving weightage to certain parameters and come up with a decision of whether I can give a loan or not. So that comes under the classification use case. And a lot of algorithms which we have and running in production and generating a lot of revenue are working in this kind of categories, either classification or clustering. Where classification talks about like I categorize the data into one or other categories, where clustering talks about, how do I segment and group them into one single geography or one single pattern type, and then based on the pattern type we can analyze like how those customers are behaving. Maybe I can cluster group of Netflix users based on their viewing patterns. I can group a lot of DMart users based on their pattern of buying, right? So based on all those things, a lot of companies have adopted like how do I do more a personalized recommendation to those users, right? For example, there are a lot of users who are going to DMart and say like they are buying say like dal, oil, and things like that. If I can't recommend a electronic product to them, right? So previous olden days we used to send coupons to everybody. Now we are toning down, we're creating more personalized kind of recommendations based on their patterns, and those patterns can be designed based on the clustering algorithms we have created, right? So those are some of the examples. So I was exactly talking on the recommendation part. So recommendation engines, these are the ones which are very, very, I would say from a business standpoint, these are the ones which are very, very important. And now we are seeing that in every area, we do see this recommendation in place. It can be enterprises, it can be retail companies, banking, insurance, or any e-commerce companies. All of them has this as a very strong use case. Again, recommendation engines where we try to identify again patterns and kind of relatability between the products, finding similarity between products, and identifying which other products have similarity, and recommend these products to the users who does the consumption. There are a lot of algorithms. I'm again not getting into details of the algorithms which we use for doing these recommendation engines, but there are a lot of these algorithms which help us do recommendations for more of a structured data, recommendations with text, and structure recommendations with images. So all those different patterns can be used for kind of coming up with some kind of recommendations. Another interesting use case we see is especially in these transportation uh, kind of and car sharing kind of business mode, where we are seeing that companies like Uber, Ola, Rapido, even the quick commerce companies like Blinkit, Zepto, all these guys are using this technology, specifically the technologies which deal with a lot of data engineering work. We do a lot of pattern recognition, identification work, and so on. And based on that, a lot of things are done. For example, I can take the example of Uber. It does Previously, it used to do search pricing, right? It used to show us like 1x, 2x, 3x kind of a thing, where the price used to be quite evident, saying that imagine my trip cost is 100 rupees, but it used to show 2x and then make the cost as 200. And people do not like paying that, saying that my cost of my trip is only 100 rupees, but I don't want to pay two times of it. So they used to go to a local auto rickshaw and so on. And but then Uber changed the strategy of not showing those 1x, 2x, and then showing the search pricing. So search pricing again is a concept in which we can analyze the patterns of the bookings. For example, at a given location, at a given time zone, at a given geography, if there are a lot of transactions happen at the same time, Based on that, we can increase the demand of a particular location, and the search gets applied on that location. And recent times, we also see that along with the search pricing, we can also give certain tip to the driver. So based on other factors, for example, is it a busy location, and an additional tip is getting added or not. If the additional tip is getting added, that's when the transaction gets pumped up into the Uber driver's menu or screen, and then he will be able to accept or reject kind of that transaction. So a lot of this kind of changes are happening, and everything is purely based on how do we analyze data, how do we find patterns of the data, and how do you put intelligence in which we can identify the best user or best driver, and recommend them so that they can go and pick up the customer. Right. A lot of these things are happening at this moment. One other interesting use case, again, we are doing a lot of experiments on this. Even a lot of academia is also doing experiments on this. Is how do we identify human emotions, right? Human emotions and human emotion analysis. Now again, people can have questions that, if we create robots, and the robots can understand human emotions, and these robots can replace humans at certain jobs, for example, say cashier job, receptionist. So will it again lose the jobs? Yes, these jobs are going to go away. I'm damn sure. And in the coming years, we will not see any receptionist, or we will not see any specific kind of cashiers and so on. And all those things will be replaced with robots. But the bigger problem we have it right now is these robots are pretty much monotonous. They do not have emotions. That's where there is a lot of work happening in the space of AI. Is like, how do I embed emotions into the artificial robots? There are a lot of movies also on this space where the robots are created, where there are emotions added to them, and then they become bad and all that stuff. I think recently only I was seeing a movie called as Alan or something like that, Jennifer Lopez movie, something like that. So it was also exactly related to it, where the robot gets emotions and then they try to control and all stuff. We are still very, very far to that level, where we can't go to that level at this moment. But these are very important, because if, for example, I can deploy a robot as a receptionist, and then the robot can understand what the customer is asking, and then can respond to the emotions, can blend the emotions of the customers and then respond to that, right? So that becomes very, very very, very good, right? So for example, I go to a hotel, and then I ask, like, can you provide me a beach facing room, maybe a room at a higher floors and so on. The robot should understand the emotions, like whether I am happy, I am sad, I'm requesting more, whether I'm angry. So based on all those emotions, it should be able to act accordingly. And that is something, a lot of research happening. Like, again, it is happening in pieces. Like, first thing is, like, how do I identify, given a video, how do I identify emotions of the video, and what times of the video the emotions are moving. And then based on the moving emotions of the video, and along with the voice modulation, is the person angry, sad, confused? All those things will come forward, right? So if AI algorithm can understand that, then feeding that information to a model, and then getting some kind of outcome is very easy. Now, this is where I was talking about the agentic AI, right? Now we are doing a lot of experiments on this agentic AI, where we create agents. So agent can do some work. For example, I want to go traveling. Um, And then if I want to go to go to say like I want to go to Goa, so I say I want to go to Goa for this year end to an agent, and then agent will decide based on a lot of things. For example, different hotels and my liking of what I would like to do. For example, I would like to do a lot of sea sports and so on. Maybe I would like to spend a time on a beach vacation. Maybe I don't like a lot of hustle and bustle, but I like a more of a relaxed kind of an atmosphere. So imagine these are my likings. Based on these likings, these individual agents, for example, there can be an agent which will be finding relevant hotels. There can be another agent which can plan our day. There can be another agent which can do the bookings. For example, I want to do sea sports like maybe like paragliding or maybe water sports and things like that, or want to go for a scuba diving, so something like that. Then there will be another agent which does the planning, and then all these agents combined together can be given as a product. And when I say either I type, say that I want to plan for a Goa trip this December, then based on our likes and our preferences and so on, it should do all that work. It can book the tickets, it can plan our day, it can find out the best hotel with best deal and can give us the best discount. It can compare various travel sites and then come up with the best recommendation and then do that. All these things are happening, and believe me or not, next year you will see a lot of agents which will be created, and most of the companies will be having those agents as a front facing agent. I am saying it's not a robot per se, but it is a software system which will be coming, and and then we will be interacting with them, and for sure. So this is going to happen, and people are already working on that right now. One other interesting area, I would say this one is path breaking, and a lot of work is happening in this space. Again, anyone interested in the healthcare domain, so this one, genomic data analysis, predominantly using a lot of data analysis and AI to determine the best compositions of drugs or best patterns in which the gene matching happens, and identifying the efficacies of the drugs on certain kind of genes and so on. So a lot of this work is happening. You might have already heard about, for example, if you take like the drug discovery or in the pharma healthcare sector, the actual drug discovery time is quite high. It will take multiple years to come up with one single trial, because it is a very lethargic process. There are a lot of compliances regulations in place, because the drug will be used for humans, and if they do not follow certain kind of rules and guidelines, it will harm humans, but it will also get into a lot of legal cases and so on. So most of the drug companies have to adhere to a lot of these compliances and practices, and it follows a very lengthy procedure in which the discovery happens. And because of data analysis and AI, what we have seen right now is we are able to cut down this entire drug discovery cycle, to a very, very smaller extent. The reasoning is like we are able to do a lot of simulation tests, and then based on a lot of these simulation tests, we can replicate at the same time on different kinds of patterns, and determine like the efficacy of the drug, and also determining the effect of this drug on certain things. For example, we test it on a rat or rabbit or monkey, and then eventually on humans for clinical trials. We can cut down the cycle in a much faster way, in which we can test those molecular genes, and also test the efficacy of the drug on those genes in a simulated environment rather than actually working on those animals, right? So the gene based analysis, the drug and drug based discovery and efficacies of the drugs has gone leaps and bounds. And the prime example is the COVID vaccine. Uh, and the reason the testing was at a faster pace is based on the data analysis only, and then we were able to ship the drug much faster, and it's helpful for a lot of that analysis. There are a lot of companies which are working, and many of my friends are working in especially this area where they do a lot of gene analysis and drug efficacy and so on. This is another fascinating area, and actually it did not trigger at the pace it has to be triggered. A couple of years back, I thought that once when the Internet of Things came into the market, when people thought that no, this is going to be a next big thing, where the devices are connected to internet and then can transmit data, and then using the data we could do data analysis and can come up with some kind of analysis, right? So that was the phase. If you say like 3 4 years back, people the internet of things came into picture, and people thought that it is going to change the world, but it did not skyrocket at the pace at which it was expected to. But I have a strong belief that this is a technology which is going to revolutionize. The reasoning is that the chips which are being developed at the edge level are becoming very popular. There are a lot of these companies which are developing more edge level chipsets, and once those chipsets become ubiquitous, then it becomes very easy for the devices to capture based on multiple sensors. It can be temperature sensor, viscosity sensor, gyroscopes, or things like that. Based on those things, we can sense a lot of information and can easily transmit. And also thanks to the a lot of communication technology we have in place, where we can transmit information at a very fast pace, and a lot of information can be transmitted. So those devices are going to make the data access very accessible, and also transmit to a central device, and analysis can be done there. So this is an example of Internet of Things for a large car manufacturing company, where what this company used to do is, imagine there is this large production line where the cars get assembled, and for example, there's a car cutting machine, and then the lathe machines and so on. All those things are operating in the production shop floor, but because they're operating at a continuously, at some point of time there will be like heat in the lubricant fluid, or there will be turbulence in the lathe machine, or there will be some change in the temperature and all that stuff. So, and if one production machine goes down in the entire production lane, it halts the entire production. So it becomes very essential for the shop floor to ensure that all these machines are working efficiently without any delays. At the same time, their parts are also replaced very quickly whenever there is any issue with one machine, right? So for these supervisors, it used to be a very tedious job that every day they used to go and monitor a lot of these parameters, the metrics in which they can sense the goodness of the machine. It can be on their viscosity levels, it can be on the temperature levels, it can be on their turbulence of the lathe and so on. So all those parameters used to be manually recorded, and based on the intelligence of the supervisor, they used to determine that okay, so and so machine will go bad, and so on. But now, because of Internet of Things, right, what we are seeing is we can keep all the sensors connected to the machine, and then it can do something called as preventive maintenance. So a lot of these manufacturing companies have these projects already in running in production. It's called as preventive maintenance of shop floor. Now, preventive maintenance can be detected based on all the parameters which are coming from these sensors. We can determine uh, based on the past data if the temperature is beyond certain limit, if the turbulence of the lathe is so and so, if the viscosity of the lubricant fluid is below the certain level. Based on all these parameters together, we can determine and say that okay, the production machine number 58 is going to go bad in another 2 days. Please change the lubricant fluid, right? So there used to be very customized messages which can go to the supervisor so that the supervisor can take actions well in advance, and it doesn't cause any problems to the um, a problem to the shop floor, right? So it doesn't cause any problems to the shop floor, and everything will be in place, right? So this is a practical example. A lot of work is happening in the preventive maintenance area, and we are seeing that there is a lot of traction in this space. But I very strongly believe, bottom of my heart, that Internet of Things will eventually take over. We would be seeing that in the coming years, every device around us will get connected to internet. Every device will have some kind of data which is transmitted, and every device will be capable of interacting with each other, right? My fan interacting with my television interacting with refrigerator. uh, it is going to happen, and in the future we would be seeing that how the device can coordinate and then understand and behave based on the information they have, right? So that's going to happen in the future, and we would see in the very near future. Now, these are the examples of a lot of these chatbot based applications, Siri, Alexa, Google Assistant, Cortana, and all these things are based on, again, now you see that every company, every customer facing application is having these chatbots, and they are backed up with the generative AI LLMs, so that it can, previously we used to do natural language based processing, right? It used to be very tough to determine what is the intent of the customer utterance, right? So what did customer speak, what is the intent of the customer, what is the crux of the message. Now all these things are very important. We used to do parts of speech analysis and so on. It becomes very difficult for the text to be dissected, understood, and from that, intent has to be extracted, and based on that, we has to respond. Now, that used to be very difficult. But now, with the large language models, because they are trained on trillions of parameters, they already have all these kind of interactions in place. We don't have to do that training. We don't have to tell that okay, this message means that this is the intent. So we don't have to explicitly tell that, and we are able to create more human like responses and more human like interactions. So chat gpt is an example of that. We are seeing that it is capable, highly capable of doing a lot of those kind of human-like interactions, and can give a lot of information based on what we ask and how we ask. I was talking about the agentic AI. So these chatbots are now going to go one step further of connecting with some kind of agents which does a specific task. For example, I want to build a flight booking app, right? So flight booking. So I can say like I want to go to Goa on 24th December. Then the agent can determine what is the best best airline can come back with a recommendation saying that, okay, this is the cheapest price, this is the airline based on your preference, these are the available airlines based on your preferable time of travel, right? I don't prefer to go with the early morning flight. It will disturb my sleep cycle. So I would like to go a little maybe in the day, right? So based on all these patterns, it will try to determine which flight is at the best deal, and then can give us the information. And then based on our response, it can directly book also. So these chatbots are going to one step further, and they will club with these agents, each agent doing a certain kind of task and maybe coordinating between the agents and providing a holistic experience. So that is going to happen in the in next year only, 2025 only. We are seeing this is going to happen. I think last but not the least, I would say that this is one of the healthcare based example where there are a lot of projects we did on personalized medicine. Specifically, there was one insurance healthcare client I worked back in 2018-19 time frame where this particular personalized medicine was one of the major project which determined like how do I do personalized recommendation of medicine based on the uh, based on the what we call as EMRs. EMRs are nothing but electronic medical records. So based on the electronic medical records of the patient, we determine the personalized medicine to that particular patient. Now, how do we derive that what is the best medicine? Again, the question can come that whether it will replace the doctor. It is not certainly going to replace the doctor because it gives recommendations. The final decision is with the doctor. It find out the patterns of different patients, for example, based on the weight, lifestyle habits, eating habits, maybe exercise habits, and other kind of elements like any allergies and things like that. Based on all these patterns, it can group the patients into certain category and determine what type of medicines were working for those patients and recommend that medicines to the newer patients. So as you see, this is an entire system which tries to work on the data analysis, come up with the recommendations and give that recommendations to the doctor, so the doctor understands the pattern and based on that take a meaningful decision. Now if the doctor has to do all this analysis and come up with like why where does this person fit and then what type of medicines will be much effective, then it needs the doctor to be very experienced or highly intelligent and so on. But nowadays, using the technology, which is very positively aiding the doctor, so that they can speed up a lot of these personalized medicine categories. Apart from the personalized medicine category, AI is also used in hospital management. For example, Narayana Healthcare, I was hearing one of the good friend from Narayana Healthcare. They are recommending AI to be used in how the hospital is run. Because when we go to a hospital, there are a lot of things happening. There is patients waiting for the doctor. There are diagnoses happening. There is some nurses who are actually validating the results, and then based on that recommending some more tests to be done. There is a lot of pre-work which needs to be done before we go to the doctor. The case histories, right, are more manual, especially in India. All the case histories are very manual because doctors write on the books, right, or the prescription books. But how do we convert all that information into a digital information and can create a patient history, case history, and then based on that, does recommend some pre-work to be done and determine the availability of the doctor, determine the queue length, for example. I know the doctor will be available at so and so time, so that you could do the booking at so and so time, and all that stuff is purely data. And based on all this stuff, a lot of analysis can be used for making healthcare much more accessible, right? So if God forbid, we don't want anybody to go to hospital, but imagine, we all know like how is that hospital experience, right? So very chaotic, right? A lot of patients are there, a lot of patients waiting at the maybe a test center, maybe they are waiting for some test to be done. So all this can be planned properly, and then so that it reduces the time spent for the patient. It improves the effectiveness of the doctor. It improves the productivity of the hospital also, so that a hospital can cater more patients, right? It can cater for more patients. It can utilize doctors more, what I mean to say, more effectively, and so on, right? So likewise, there's a lot of that kind of analysis which is being done. Well, let us get, I think this, I'm not sure how, so I have another session which is on Saturday, I guess, that will go very deep into like how we do each and every process. For example, in machine learning operations, practical AI machine learning operations, what are the different tools? Because I lead that ML engineering practice, where we have different products under the MLOps era, where we create multiple products which cater to individual actions in the ML process. So we will go in deep detail on how individual things will work, and that session is again catered for that. But to take you a very simple process, right? Machine learning process, the way it works is we collect a lot of data from the data providers. So the raw data goes into something called as a data pre-processing, where we do a lot of pre-processing of the data. We can combine data from multiple sources and does the pre-processing. And once the pre-processing is done, we feed a lot of ML algorithms. There are different set of ML algorithms which are used: supervised learning, unsupervised learning, reinforcement learning algorithms. All these algorithms, the holy grail purpose is to create a pattern identifier, create a model which can be deployed into production. Either we deploy the model in a batch mode or in a real-time mode, and that model will be responsible for doing the predictions. So we saw a lot of examples. We saw a lot of those examples in which it does the prediction saying that can I give the customer this loan or not, and if I want to give a customer a loan, how much loan I should give. So there is one prediction saying that loan eligible or not. That is one prediction. But the second prediction is saying that how much loan is eligible. So I can get like 2,55,000 loan. So that is a numerical term. So an algorithm which basically determines such kind of numerical values, we call it as say like regressions. So regression based algorithms, but the ones which will determine more of a class outcomes, we purely call it as classification based outcomes, right? So there are different sets of algorithms which will be used for getting this outcomes, and and then these golden models are deployed in a real-time mode. So I'll show you examples on what are the technology stack which we use for deploying the models into production, and what we will use for deploying those into production. Many a times in academics, we learn only one piece of the entire ML life cycle. We take a model, we learn 100 models, right? We will learn about decision trees, regression, random forest, and different types of forests, and so on. And we spend too much of effort on learning a model or a type of a model, and satisfy with certain kind of metrics of the model, saying that accuracy or precision, recall, and so on. but actual work is not just creating of the model, but how this model is deployed in real time, how the model is monitored, how do you identify the change in the model, how do you determine the drift of the model, how do you determine drift in the data itself. So all these are very very important features. And in the MLOps life cycle, we see that how those different pieces fit together, so that whatever prediction we are doing is working at the highest precision. And also we are trying to identify the changes in the data, changes in the model, and proactively correcting them, so that my model which is running in production is giving the best results, right? So we will understand it in my next session. I hope you guys will come to that session also. So just few more slides. I'll talk about, okay, this is about the neural network, how it works. So it's a pure depiction of how these neural network works. This is the example of the neural network. Yeah, a few slides. So if you understand about what is that entire area in which we need to concentrate, three important areas. We need a deep understanding of math statistics. We need a good understanding of a substantial expertise in subject matter expertise, and also decent programming skills. When I say hacking skills, it's about decent programming skills. So if you have all these together, then we can create very very good algorithms and models which can be used in production, and also generate revenue, right? So creating an experiment, creating an ML algorithm is easy, but how do you productionize it and how do you generate revenue out of it is something is very important. And that is the key. That is the key for um, for that. All right, so I'm going to go check the time. I think 40. So we have, I think, 10 minutes more. Probably I'll stop for any questions.
Okay, participants can raise your hands in case they want to ask any questions. Okay, 2 minutes. We are unmuting you. Yes, your mic is audible now. You can ask.
Yeah, good evening, sir.
Maybe.
Yeah, sir, there are so many machine learning algorithms are there. No, you told around 50 ml machine learning algorithms. But how to select the particular algorithm for a particular problem, sir? Is there any specific route for selection of the algorithms? Because algorithm is a procedure of what you call as steps. Okay, so suppose if you take the data, after that for the data, how the algorithm is working. But a particular problem, how to select a, this algorithm is suitable or this algorithm is suitable. Is there any procedure, sir?
Yeah, so I can give the practical approach we follow. So what we generally do is, many times the basic models also work very well. We have one understanding that what type of problem you are going to solve. As I told, that if I'm solving a classification problem, there are suite of algorithms which come into the classification problems. If I'm going to solve a regression problem, again there are suite of algorithms which come into regression problems. So first question we will ask is like, what type of problem I am solving, and then come to a one step down. So there we can cut down a lot of unwanted algorithms and then can focus on certain set of algorithms. Now what we do in real world is we try to go with a first basic simpler algorithm and try to construct the end-to-end use case with that algorithm. We can take as simply as decision trees. The ones which we like the most and they are used most are XGBoosts and random forest. These are one of the very popular, and third ones are SVMs. So these are, I would say, universal algorithms, work for most of the cases and give very decent results. So what we do is we don't do a lot of algorithmic comparison and spend time on that. The one which is important for us is, can I create the end-to-end pipeline where I create my algorithm, take the data, give some result, and show some outcome, and then take a feedback. So unless until I get that pipeline ready, I will not be able to gauge the performance of my algorithm. So what we give more preference is not on the accuracy of the algorithm, but the effectiveness of the algorithm and how quickly we can roll out the pipeline. So if you ask me like which ones to choose, generally in industry we choose these three major ones:
Okay.
XGBoost, random forest, and the SVMs. These are very easy to
Popular.
pick and gives very good result.
Yeah. Thank you, sir. Thank you very much, sir.
Okay, any other participants? Please raise your hand. Anyone who wants to ask any questions? Okay, Praveen Kumar, please wait. Guys, mic is enabled now.
Sir, good evening, sir.
Good evening.
Uh, could you suggest that, okay, so for education industries like, okay, universities or colleges, okay, so what could be the best products, okay, so which we can generate or develop for them? Any ideas, sir? Coin.
Um, as I was talking, right, sir, I was next year I was saying agentic AI is going to change the way in which the projects are done, right? So project ideas will be mostly around what these agents can do, but I would recommend learning on how these agentic AI work. There are a lot of these newer frameworks which are coming in LangChain, LangGraph. There is similar tools like Crew AI. Even OpenAI has released a agentic AI framework called a Swarm. So these are new frameworks which are getting released, and very new entrants, I would say. And any projects which are done using them will have a lot of value. Now, what application you can use is like more generic. For example, can I create a travel agent, right? In fact, there is one other interesting work which was done on agentic AI where, for example, doing research, right? Research is a very tedious task, right? I have to go look at multiple research papers from different journals, from different articles, and then come up and condense that information into a one research article, right? So this is the bigger problem, and I know that there are few universities which are working on how do you create agents which can do, for example, like searching right research papers, which has the most accurate comparison, and then coming up and condensing all the research papers into a final research article, right? So so such kind of work is happening, and the sky's the limit of how you can create products out of it. But that is something. For example, there is another work happening on identifying deals. For example, we have Amazon, Flipkart, and different kind of uh, companies, right? Retail companies which are having deals. But how do we identify deals? Identify the right deal, get the justification for the deal. For example, the product is much lower than the original value, then that is like a steal deal. And then also booking that, right? So this is one other work. Again, in the agentic AI space, there's a lot of work happening. Like, how do we determine the deals? How do we identify the worth of the deal? And then giving a push notifications to the mobile apps whenever, and this is all happening in the real time. So such kind of applications are being built. So I would recommend do a little more research on this agentic AI space, and there will be a lot of projects which you guys can do.
Sir, one more, sir. Okay, so could you give any one or two, okay, so pioneering projects, okay, you implemented in the DBS, sir, in your bank?
No,
Then
that
you.
becomes, I have already spoken about in a generic sense. I can't give more specifics,
Right,
right?
sir. Right.
What I would recommend is, if you guys can connect with me, say one on one, maybe we can discuss, because at a generic level, I will not be able to reveal all the details.
Sure, sir.
But I will be happy to give more nuances that what we are using and how we are using. But it becomes our IP. So sorry for that.
Sure, sir. Thank you. Thank you very much, sir.
As we are on that, I would like you guys to ask if you guys can connect with me on LinkedIn, because that is the platform. Many times I get requests saying that how can I reach you, and how can I connect with you and so on. I would
Yesterday I
recommend.
connected, sir.
Yeah,
Yeah.
LinkedIn is a good mechanism, sir. So, and even if you guys have any further questions or any things like that, then that would become easier. Okay.
Okay, any other participants who wants to ask any question? Final call. Okay, then in that case, we are going to close the session. Dr. Satyavrata Singha sir is requested to propose the vote of thanks.
Good evening once again, everyone. On behalf of the organizing committee of ATAL FDP on AI and quantum computing, the future of intelligent systems, it is my privilege to extend our heartfelt gratitude to Mr. Sitaram Taripoli sir, Vice President ML Engineering, for his insightful session on demystifying AI, the next frontier. Mr. Taribali sir, your session was both enlightening and thought-provoking, offering us a deeper understanding of the transformative advancements in AI and the exciting possibilities ahead. Your ability to simplify complex concepts and share real-world insight has truly inspired us all. We are also equally looking forward to your next session on the sixth day, where you will explore AI operation in the real world with practical applications. We are confident it will be another enriching and impactful session. A special thanks to all the participants for their active involvement and thoughtful questions, which made the session more interactive and engaging. Your enthusiasm and curiosity are what make these session discussions so meaningful and dynamic. Thank you once again, Mr. Tarabali sir, for your valuable time and contributions. Your knowledge and expertise have added immense value to this FTP. Thank you all. Over to you, ma'am.
Thank you, sir. Thank you for giving a very nice session, and thank you all the participants. Tomorrow again, same time, we'll meet at 6 p.m. Sharp. Do join 10 minutes before the session. Thank you all.
Thank you very much. I have put my LinkedIn in the Q&A. If you guys want to connect, we can connect. But thank you all, and we'll meet some other day. Bye bye.
Goodbye, sir.
Are there any questions? Someone is raising hands.
Please wait. I'm just unmuting yourself. Yeah, you can ask your question now. Says Bhanu. Marila says Bhanu, you can ask your question. Are we having any question? Okay, no, nothing. Okay, anyways. Okay, then thank you all. Thank you,
Okay,
sir.
ma'am. Thank you
Bye.
very much. Bye bye.